Hjärtligt välkomna, very welcome to the first in our series, our renewed series on open science lunch lectures. We're very pleased to have Professor Stefan Wiens here. I'll just say some introductory words first. As I said, by the way, my name is Joachim Philipsson. I work here as a research data analyst slash curator slash steward at the University Library. And as I said, this is the first in our renewed series on open science lectures that we haven't had for a very long time. I think our last was more than a year ago. So we are very pleased to have this first occasion. It so happens that only within 2 weeks' time, on the 22nd of May, we will have our next speaker coming here, Professor Erik Lindahl from SciLife Lab and Biophysics. He will also talk about open science and in relation to the Plan S. I don't know if any of you were present when we had a seminar on Plan S here in January. There was a lively discussion, and Professor Lindahl made a great impression on us because he tended to see both sides of the coin, the flip side and the back side of what's the effects of open science and Plan S. But now we're very much pleased, and I'm personally much pleased to welcome Professor Stefan Wiens, who is a professor at the Department of Psychology and specializing, as I understand it, in psychophysiology, yes. Which, as long as I've gained some insight, means that you're looking into our heads and the various stimuli, the impressions that they make, and you work with brain scans, yes. Is that correct?
Yes.
Yes, and one further reason why I'm so pleased to welcome you here is that Professor Wiens is actually I would say, our best customer in publishing open science in Figshare, in our Figshare instance. So we've been working and discussing a bit back and forth together, and now I will leave the floor to you, and you will explain to us. You will talk about pre-registration, as I understand, and maybe not everyone knows here what pre-registration is and its relationship to open science. So we're very curious to know more about it. The floor is yours.
Yes,
thank you.
Thank you very much. Thank you. Yes, thank you all for coming. And yes, my background is in psychology, but and yes, in psychophysiology. So I do like brain imaging of awareness and consciousness. But I won't talk about this today, right? And this is like a lunch meeting, so it's supposed to be informal. So feel free to ask questions, and actually it will be interactive because at some point I'll ask you to answer questions, and I use Menti. So if you have used this before, you go to the website and then use this code, but you will see the code a little bit later. So I chose this titled Scientific Research, the bad and the pre-registered, to not to offend anybody, but just like to raise your interest, and I hope I'll be able to convince you. So what's scientific research? I think to me the goal is to understand the world better, right? So that's what science is about. To understand what are the clouds, what's under the clouds. Like I work on the brain to understand like how does the brain generate these wonderful processes, attention, memory, awareness, and so on. So, and scientific research is simply put about having systematic observation. And for many people it involves experiments, right? Sitting in the lab and doing these complicated experiments. Doesn't have to be, but it's part of it. Like that you have systematic observations, and then you have certain ways of reasoning from your observations. You know, how you use them, and you have like inductive and deductive reasoning, and then you have theories, and you come up with theories, and then you derive predictions from them, hypotheses, and you test them. Okay? So, but then the goal is to understand the world better, how things work. And I can tell you a bit about my background. I'm originally from Germany. And when I studied at the University of Hamburg, I had some professors there, and they insisted that everybody call them Herr Professor Doctor. Yeah, I'm not, Herr is like a male person, so unfortunately it was really biased at that time. So towards men. And they really, they were like, I am a better person for being a professor because I know it and you don't. So actually I had one professor, and when somebody asked a question, he would ask, how far have you come in your studies? Have you passed the intermediate exams? And then when they said no, he would refuse to answer the question. He would say it's a stupid question, without disregarding the question. And to me, I didn't like that. I thought this is not how science should be. It should be about like using methods, and then if somebody has good ideas, then it doesn't matter where they come from. And as part of my studies, I was supposed to do a practical training for half a year, work in a company, for example. And I didn't want to do that. I was like, I want to do more research. Where can I do that? So I asked, I worked as a research assistant for a professor. I asked him, can you suggest somebody in the US who's really good at research and who's nice? And then the professor told me, yes, I know somebody, and at Katkin, at State University of New York at Stony Brook. So I contacted him, and we worked something out. I could visit him for 1 year. I was then enrolled in the master's program, and he picked me up from the airport, and I was allowed to stay with him for the night. And he asked me, basically, almost his first question was, what do you want to do with your life? And I was like, oh, okay, tough question. And I said, I really like this research idea. Yeah, I would like to become a researcher in psychology. Okay, he said, that sounds really nice. And then he asked me, who was your supervisor? And I was like, what is a supervisor? And he said, but you had a professor there. I was like, yes, but I worked as a research assistant for him. I ran his errands, basically. Yeah, I did what he told me to do, and not like a supervisor. And then he told me, oh, it's like his perspective was completely different. For him, it was like a supervisor was really important. He said, like, science is a skill, right? So instead of like painting walls or building furniture, science is just another work. Yeah, so a skill that you pick up, that you learn, and then hand on to the next generation. So he actually had an academic tree that he tried to go back, like how far he could go back. And I'm not sure if, I know he could go back to Charles Spielberger, but then also if he said like a colleague or himself, I haven't followed it up, but that they could go back to William James. And that's pretty amazing to really think about this like historic perspective, that you learn the trade from somebody. And I really like this approach, that it's like a craftsmanship that you learn, and it doesn't mean that you're a better person. It's just like you do this kind of job and try to do the best you can. In the last few years, there has been a discussion, like in science, as scientists, are we doing the right thing? So it's not about that scientific method is wrong. It's more like maybe we are not doing it as we should be doing it. So there has been, in a survey a few years ago, many researchers, 90% of the researchers experienced there to be a reproducibility crisis. And half of them actually said there was a significant crisis. So what it means is like, you know, they would read articles and say like, oh, here's this described and this effect. And then when they try to do the same thing, they couldn't replicate these findings. They would get something else. So that's odd, right? You would think like, oh, if somebody showed this, it should be true. And so there's a discussion of, are we doing it correctly? Yeah? Or are we missing something? Are we making some mistakes? And now actually I would like to invite you to go to menti.com and ask the following question. Here's an archer, and is like taking aim, shooting his arrow, his or her arrow. And when would you think like that splitting the arrow is impressive? Yeah, when would you say this is an expert arch person? Man or woman? Expert archer. I think I can do this. So I'll give you a few minutes. Please go into this and write something. When would you think this is impressive? Right? It should be, if you go to menti.com, it should suggest this code. Because that means it picks up where you are, and this is the closest presentation. Otherwise, you have to enter this number. I have 2 responses. A few more, please. All right, should we do this now? Then? Yes, it's always impressive, right? It's totally amazing to do this. Actually, when I Googled, I found a video where somebody was able to hit an arrow inside another one. So that's like, yeah, how often can you do this? So always, yes, it is really impressive. But I think one is like when you intend to do it, right? When you predict it. For most people, it would be like, wow, this is so amazing, I split the arrow, that's pretty cool. But then to say that it doesn't make you an expert, right? If you can predict it, that's when you're an expert. When you can say, you call your shots, right? When you're saying, I'm going to hit this target now, and I'm going to hit that target now, right? Not just like shooting at stuff and then saying, oh, I managed to split the arrow. Looks. Yes. Okay. Right. So here's that you intend to do it. You called the shot. And so what about this then? Right. I just take an arrow or like a gun and just shoot violently at the wall, and then I go up to the wall and paint the bullseye afterwards. That's not impressive, right? So it is impressive if you call the shots, if you say beforehand, you predict it, this will happen. And that you didn't try it many times, right? You might say like, oh, look at this, I managed to do this on my first shot, but maybe you already tried it before, right? So it's like impressive if you do it, if you predict it, that this will happen. And the same in research, it's called confirmatory research. If a theory can predict what will happen, then it's a good theory. Right? So the findings are predicted, and you start off with a theory, and then your goal is to test the theory. Right? You say, this is what happens, this is how the things work. So then you have your theory, and you derive hypotheses, and your hypotheses predict what will happen. If I do this, then this should happen. Yeah? So it's really important that the theory predicts what will happen. Right? Do you see my point? It's like with an expert archer, can predict what will happen, then this person is really good. And the same with the theory. If good theory can predict what will happen. So how do you prove that when you do a study, that your hypothesis, your theory and hypothesis came before you collected the data? And that's where pre-registration comes in. And pre-registration, there are many different websites that allow you to do that. But I'll only talk about this one open science framework because I work in psychology and it's very convenient to use. They have different templates that you can use, and it's for free. So open science framework, and here it allows you to pre-register your hypothesis before collecting the data. So you get a timestamp. You say, this is what I'll do, and this is what I predict. So here's an example. That's actually the first study that we pre-registered, my graduate student Rasmus Eklund and I. So we put in the title, and then authors, and then the research question and the hypothesis. And then there's a timestamp. And then we also said that we did not have any data. Yeah, so the data would come after the hypothesis, right? So that we couldn't cheat. And what is really nice, you have the timestamp, and it's also a public record. Yeah, so you can embargo it by 2 years. You can say like, if you're working on a hot topic, you don't want other people to know, so you can pre-register it and say like, wait for 2 years before it becomes public. But this is really nice, the public record, because then it keeps track of like failed attempts, right? If you pre-register a study and then do the study and then it fails, then maybe you say like, I'll sweep this under the carpet because it might show that my theory is wrong, you know, and I love my theory so much, so I don't want to give it up. But then because it's pre-registered, there will be a public record of this attempt. You pre-registered it, so somebody can ask after 2 years, like, what happened? Why didn't you ever follow it up? And it will be embarrassing, or it would say something about the theory if there's one attempt that worked, and then lots of other attempts that are never published, right? But you have a record of it. And what it also reduces is the file drawer problem that has been described many years ago, that people would do a study, and then when it didn't work out, they would just toss it, basically, or just say like, nah, I'll just put it in the file drawer. Right, so then you will know that this, right, there are two parts that you predicted that will happen, what will happen, and then it also reduces these studies that are done and just you never hear of them. So in terms of research, people talk about confirmatory research, right, where you really test the theory, to see like, is it a good theory? And then the other side of the spectrum is exploratory research, where it's totally fine to go and you start off from the data, and then you try to make sense of what you have. And for many people, it seems like they like this better. I think both are really important. And like from what I've read about like philosophy or science, they say this is like a cycle, right? At the beginning, we don't know anything maybe about an area, so we have to collect data and see like, so this would be exploratory research to see like, can we make sense of this? Can we draw some kind of bullseyes in there, right? To say like, here's something happening, here's something happening, putting the pieces together. And then we can say, I think now we have an idea how theories work. And then we can go to confirmatory research. And unfortunately, most of the time, the nature doesn't comply with our wishes, right? So it may be partly true, but then some of the results don't fit. So then we have to go back and use these data to change our theories. All right, so then, this is research, right? Where you have exploratory research, confirmatory research. But as academics, we live in the world that we have to publish. Yeah, very often, like in science, it's actually part of the definition of science, I think, that things are published. Yeah. So now, what do you think will increase the chance of publication? Yeah, so if I may ask you to go to Menti and just rate, what do you think? Like if somebody has clean results, straightforward story, novel, surprising findings, right? If you're not in research yourself, right, you can just imagine, like if you were a researcher and you are sending this to a journal, what will sell best? All right, nice. So answers are dropping in. So clean results, straightforward story, novel, surprising findings. Yes, you're all correct. That has been shown that all of these are really important. It's like they just sell better. Yeah, it's a little bit of a tabloid culture. It's like if surprising findings, novel, and the story is really like an arrow. It's like, and your results look really clean. You have a really high chance of getting published. And in scientists, we have this academic pressure to publish, right? Even like for graduate students, it's now a requirement to get a PhD. You have to have publications, at least in our department, I think 2 or 3 publications. And so then as a researcher, you have this pressure in a way to deliver what is desired, right? So if you have a better chance to get published, if you have a straightforward story, clean results, and novel, surprising findings, you try to get that. All right, so now I want to ask you, surprise, right? So getting surprising findings. So here I have a dice, and I tell you I rolled it, and I get 10 sixes in a row. How surprised would you be? You see the image, right? It's like, no. Where's the picture? Yes, right? You see, this is the dice. I rolled it, and I get 10 sixes in a row. How surprised would you be that I had 10 sixes in a row? Very nice. extremely surprised. Right? You would be extremely surprised. Okay, but what I haven't told you is this. Right, so now, all you knew beforehand, that I said I voted, and I get 10 sixes in a row. So now what about these two situations? So in the first one, I actually voted 10 times. In the other one, I voted 100,000 times. Right, exactly. Right, you would be extremely surprised, and I assume that's how you interpreted it the first time, right? When I said I got 10 sixes in a row, but unless I made a mistake, I didn't say that I only voted 10 times in a row, but you assumed that's what I did. But I didn't tell you. So right here you were in a way fooled by or misled by your assumption. You assumed I'd only voted 10 times. But now, actually, when I tell you I actually voted 100,000 times, you wouldn't be that surprised. So in a way, you have to know, to judge how surprised do I have to be, or should I be, you have to know what I actually did. Yes? So you have to know how big was the search space. So you have to know, if you think here this trawler, you have to know how big was the net. If it's a small net, right, if I say I only voted 10 times, then it's more convincing. If I say I actually had a big net, that is sometimes called a fishing expedition, right? If I just give me everything. And just to mention an example, this study by Luck and Gasperlin, and because it's relevant to my own research, I work with EEG, so electroencephalography, and you get so electrical activity of the brain, and you get 256 electrodes, and you get 1,000 samples per second. Yeah, so you get lots of data. So, and then you have different conditions. And in this study, they only had 10 electrodes, and then you get these nice ERP waves, electrical waves. And here the point was that they said they basically did the same thing throughout the whole experiment. But then they randomly divided up the trials into two conditions. They said randomly half, we call them the frequent non-repetitions, and the other ones we call the frequent repetitions. And they were basically the same trials, right? You had 100 trials, and then 50 go in that stack, 50 in the other one, just randomly. So you wouldn't expect any differences. But with this much data, just by chance, something will come up. And they see actually, it looks like meaningful. Oh, look at this, there's this little bump here, and there's another little bump. And if you work in ERP, this might look real. Yeah? So because then the real peaks actually may look like this. So, but what they showed, if you just have enough data, something will always pop up. Yeah? So you have a wide net, so just something by chance will pop up. And also, here the thing is, if you have lots of data, something will just pop up by chance. But even if you don't have a lot, there's still a lot of researcher degrees of freedom, it's called, in a nice way. And just they don't talk about eggs, but I just used it as an example. Think about an egg. If I give you an egg, it's like a simple thing, right? I mean, it's very complicated, but it's really simple. It's like one ingredient. I say, make something with this egg. And you would think it's like one ingredient, what can I do? But you have a lot of choices, right? You can boil it. You can say it's a soft or hard-boiled, you can fry it, you can scramble it, you can poach it, and many other things. So with the same ingredient, you end up with different outcomes, right? It's completely different dishes. And the same thing in research. You don't need to have a lot of data, you can have a little bit of data, but depending on what you do with the data, you end up with different things. And this has been more nicely described as a garden of forking paths. That depending on where you turn and how you wander through this park, you end up in different places, right? So it's not like the data are there and then the analysis are given. It's like all these small decisions that you make. What should I do with these data? Should I take the mean? Should I take the square? Should I leave out this person? Should I do that? It all affects your outcome, right? So depending on all these small decisions, you will end up different So that's called the garden of forking paths. And it may be okay if people took these decisions randomly. Yeah, if it were just happens, they'd make this decision and that decision, because then it wouldn't be biased. But unfortunately, what has been shown that many researchers, they apply questionable research practices. So they leave out variables, they leave out conditions, they select studies that worked. Right? Goes back to the file drawer problem, that they would just say, it doesn't seem this works, so I'll just put it in the file drawer. They report an unexpected finding as predicted, right? So as this study with Luck and Gasplin, this EEG study, where they find these peaks. After the fact, they could make up nice stories about why would they find this, and it's so amazing and surprising and so on. It's so awesome. And that's called harking, hypothesizing after results are known. And or you would stop data collecting after getting desired results, right? You just peek at your data. Does it look in my favor? No, then I'll just collect some more data. And the results, they vary by chance, right? So then if you pick it when it's actually pointing in your favor, then it's biased. But I have to say, like this, it sounds now like data. You torture the data until they confess, like as if researchers are these evil people. But it's actually I don't know most of the time, but I think most people, I think they're good researchers, right? They want to be good researchers, but then it just happens unintentionally that what they've learned, what they are told to do. It's also like if journals. I can give you one example because I've done this myself. That I actually had one study where we had a main idea, that this is the primary goal. And then we said, we also have a secondary goal and the tertiary goal. And the tertiary goal, I was completely uninterested in this, to be honest. But then we collected data. The first one didn't show anything. Yeah. The second goal didn't show anything. And the third one showed something. So I submitted this to a journal. And in this order, I said 1, 2, 3. And the journal said, nobody wants to read about the stuff that didn't work out, 1 and 2. So now it looks like as if this tertiary goal was like the main goal, and this is what we really predicted. And it was more like it just popped up. So it makes it gives the impression that we were like these archers that had this, we predicted that this is what will happen in perfect aim. And no, it was actually, this looks like something when we fished a little bit. So it happens really easily. And then also if you have this, from journals that you have to get publications and this is what they want, give us the clean story. Don't make it more complicated. Or like I have this from reviewers that they say, but here it looks like you have an effect. This is what you should look at. But it's like, yes, this is completely after the fact. Yeah, it's emphasizing the data, not the theories. All right, so I have to, right, I hope you see this, that I'm not saying like scientists are bad people. It's just like these practices are not good. So that the data torture has often been unintentional. So, but then to really show that, right, to avoid these things, to show like these decisions, how you treat your data, like what you do with the egg, right? That it wasn't that there was your decision to do it this way, that you treated it this way. So you should then also pre-register the methods and the analysis. You should commit to the study details, right? Because there are so many decisions that you make, and you should be upfront. Like, when did you make this decision? And when you pre-register and say, like, this is how I'll process my data, right? Then it's unbiased what comes out. Because then, right, it's not that you peeked at your data and say, if I take this turn, if I use this filter, it looks nicer. I'll go with it. So then you commit to the study details. You define the search space, right? You say that this is actually what I'll record. Yeah, I will collect the variables. And then it avoids this forking paths because you then already define, like, this is what I'll look at, and these are the steps I'll make. And it reduces selective reporting, because then you can't just sweep stuff under the carpet, right? If you said, I'll measure these things, then people later can look at, like, what happened to these variables? When did they disappear? When did these conditions disappear? And this is important for any research. Does it have any practical consequences? I like this example from Kaplan and Ehring. They looked at really large studies from the National Heart, Lung and Blood Institute. and that I think each study was at least $500,000 per year. Yeah, and then they looked at over time. What did they find? What did these studies find? And at 2000, after 2000, the studies were required to define their primary outcomes. Yeah, so they had to commit to their primary outcomes. What were the measures that they were really looking at? And this was so cardiovascular disease, right? So then you can see that there are a lot of ways of defining it. What's cardiovascular disease? Huh? Yeah, I don't work in this field, so I can't. But in the article, they had a whole list of different outcome measures. Right? It's all, yes, it's all cardiovascular risk. But yes, you can define it in many different ways. And what they found was, like, before 2000, there are a lot of more pluses, right? There are many more studies that found positive effects of the treatment. And now suddenly, after 2000, the rate drops, right? So, and this is a historical analysis, right? It's not an experiment, so they didn't manipulate this. But they looked at other variables, and this was the best one that they could explain this drop. That's like here, people could basically pick. Right? They could say, oh, I mean, mortality or like disease, they can define it different ways. It could be like blood pressure or some other blood measurement and so on. So you pick the one that gives you a good result and report that one. Was here, they had to commit beforehand. And then you get the drop. Right? So this is more idealistic and this is more realistic then. Right? So, but now, do you see a problem? Like, as researchers, if journals continue with this tabloid culture, and say, like, we want clean results, we want nice, we want surprising findings. Yeah, try to submit this will be very hard, right? So if you pre-registered and committed to this is the outcome, you may be punished because your results are more realistic, but they're not so nice. Like, we want the fairy tale in a way. So some journals have actually responded to this, and they have started with the registered reports. That's a journal submission format. And what they emphasize is that results are not the author's responsibility. Right? You see here, it's like what comes out shouldn't be the author's fault, or saying like, oh, you didn't get like a positive effect, so you did something wrong. Right? It should be that it's not your responsibility. What you are responsible for is picking a good question, a good research question, and picking a good method to study it. Right? That should be your responsibility. And what comes out of it is like blame nature. Yeah. So they emphasize that and say like, okay, we have two stages. The first stage is that you submit your design. So why do you want to do this study, and is your design good? And then you have peer reviews, so other experts, they evaluate this, and then you get an in-principle acceptance, so that they promise you, we'll publish whatever you get. Yeah? Just if you do this study as you promised, we think it's a good study, and it doesn't matter what the outcome is, right? Because you shouldn't be blamed for it. And so then they have, after collecting the data, they have another review where they have to check, did you comply to what you promised? And what is nice for researchers is they have this in principle acceptance, right? They're not blamed for if the results aren't clean and surprising and so on. They're just responsible for doing a good job, designing a good study and collecting the data, analyzing as they promised. And yes, and also another part that I really like, it avoids this carking. It's called criticizing after results are known. And it's actually the reviewers, if they've been shown, like if you give reviewers a study and the results bias them, right? And that's wrong. It shouldn't be that way. Like you should judge a study on the basis of the question and the methods, and not look at the results if they fit with your theory. So they have shown that if people are like really like sophisticated researchers, they get fooled in a way. They get misled by saying like they think like if the results, they're like, wow, this is really cool. This, I've been looking for this, and now finally somebody showed this. And even though the study was kind of crappy, the design, they are convinced by it. So it avoids that, right? That you punish the researcher for the results instead of punishing nature in a way. So actually, I have one example that really upset me that I always use from a pretty good journal of, yeah, I don't know, pretty good, but like a famous journal, so to say, that they said the editor rejected my manuscript and said like the study was really well done, was really well executed, but you must have done something wrong because you didn't get a significant finding. Yeah, you're laughing, right? Because it's like, so they didn't, yeah, it's like really wrong, right? You should judge by the quality of the study, not by the outcome of the results. All right, so somebody I wanted to mention at the very end who's been very, like at least in psychology, like really, really pushing this, is Brian Nosek. He's the co-founder and director of the Center for Open Science, and they actually, it's a non-profit organization, and they run this open science framework and offer it. Yeah, because you can imagine it's pretty demanding, and they have like different templates and so on. And I checked yesterday, and they're now up to 290,000 pre-registrations. And if you want to read a really good article that reviews all of these points and so on, please look at this, by him and his colleagues, The Pre-Registration Revolution. So now I actually wanted to finish by asking, like, did I convince you? Do you think it's useful for scientific research to pre-register the hypothesis and to pre-register the methods and results? The pre-registered. I was hoping I would not make this mistake. Pre-register the results. I know what will happen. The pre-register methods and analysis. Yes, so that's what I hoped. So I hope to convince you that this is good science, right? To do this pre-registration, because you can really pre-register an hypothesis allows you to distinguish, like a theory should predict something, should predict the results, and then if the hypotheses are pre-registered, you can check, did the hypothesis come before the results? And the other one, pre-register methods and analysis in any study. There are so many decisions that you can make. You should, and like what variables do you collect, and so how do you process everything, that you also want to do this. Like telling people, like, this is what I'll collect, these data, and this is my plan, how to process it. In exploratory research or confirmatory research, same. All right, so thank you very much.
Hello? Yes. Oh, thank you so much. It was really an eye-opener, I think, to me and to hopefully to some others too. We open for questions, and if yes.
Hello, thank you very much. I have a question about one of the last slides. You were mentioned this practice that some journals had started working in this new way to peer review after the design study. How common is this practice, would you say? You mentioned that some journals work like this.
Yeah, I know Cerebral Cortex does it. Chris Chambers has been really pushing it because he thinks that's the only way to do science, because then you really avoid punishing researchers for that you judge them on the basis of their results instead of judging them on the basis of the studies. So I think more and more journals offer this, and but not all of them. So I don't know, like in psychology, I have this actually that I had this one study with my graduate student Malina Tchaikovska that the reviewer said it would be nice to have more data. Yes, they liked our study, and we actually don't find an effect compared to other studies. So, but they were like, we like your data and we like your approach, but it would be nice if you could have more data. And then, like, different reviewers suggested different things. You could look at this, you could look at that, you could look at that. And then I thought this would be really nice for a registered report, right? That we say, how about if we do experiment 2? And now, can we get a proposal that you all agree on? right? Because I wanted to avoid this, that we do an experiment too and focus on these things. Yeah, on part we can't address everything, so we have to be selective. And then we send it back, and then some reviewer says, no, you took the wrong thing. I would have liked the other one. Now, after looking at our results, so I thought, like, I want to avoid this. So I said, can we do a registered report? And the editor said, actually, he said it was a really nice idea, but said that it's not possible at the moment. So they don't allow this right now, but he's working on it. But then we did an informal registered report. So I wrote a little summary of what we are planning to do, and then he sent it out to the reviewers. And then, of course, and then we got feedback from them that they said, "Oh, this we really like, and this you should fix this," and then we would be happy. But it's all informal. But I thought it was nice because then it's like they can still chicken out, right? Or they can withdraw their support, like looking at our data and saying, like, "No, thumbs down because we don't like your results." But I think it's more, it sounded that they were like, okay, yes, we can't expect you to collect hundreds of studies until we are convinced.
Over here.
Hello, thank you very much. My name is Julia. I'm not a researcher, but I feel kind of shocked about how things work. So what's your idea on how to like flip the system? Like today, it only relies on the researchers' goodwill, or I mean, it's really.
You mean what are you shocked about? That it's.
I'm shocked about that it's working like this. That you can choose what hypothesis you worked on. I mean, you can choose it afterwards, after you collected the data, and you don't. When you don't pre-register.
Yeah, in the past it hasn't been possible to pre-register, right? Or you could have like a Word file. I thought for a while, why not just have a Word file? You create a Word file and you have it on your computer and it has a date stamp. But you can fake that and change it and so on. So I like this. So this is more like now there are tools to do better science. So it's more like, I think like before it's like because of I mean, if you think about researchers are not better people. They're like everybody else. And then it's like, oh, I have to get more money. If I apply for funds, they say, okay, we'll give you money. Now give us the products, give us publications. If I said, yes, look at this, I did all this work and it failed. And the journals, I mean, it failed. I didn't get a finding. Or the journals would say, I'm not interested. I have this actually in many occasions, unfortunately, that I can't replicate what other people have done. And then journals said it's boring. Because somebody proved in the 70s that there is this effect with 5 subjects. And then say, if I have 100 subjects, they say there's nothing new to learn from this. Right? So it's like sometimes also that even people who do good work, they can't get it published. So there's like the whole, I think what has to change is like what scientists get rewarded for. For example, this part, like pre-registering, like some journals seem like, so who cares? And other journalists say, it's like finally somebody who says like, I pre-registered and sees the advantage. Now there's like clear, we did not massage our data. We didn't, we published the scripts, right? We published the data, right? So that to make sure that everybody knows, can see that what we did is not like cheating. Right? So I think it will be improved that if people use this open science and share their data, and are open with this and show that they are pre-registered, everything, and then also the incentive structure that funding agencies support this, and that journals support this, right? That they are saying like that they're not saying like, oh, it's not really an innovative finding, so we don't care, right? In many cases, that's right now it is like journals are like they want to, the more far-fetched, the less likely this is to be true, the more convinced they are that let's publish this with less data.
So you say it's the fundings and the publication system or the journals that are like the biggest
The journals, I think, yes. I think also I think people should be like funding agencies should say like, oh, you pre-registered your study, have a good idea, and no matter what the results are, right? And I think now there are ways to publish the results no matter what, right? But before you had to like deliver something to the journals, right? It would be like trying to sell to Aftonbladet something, and then they were like saying, this is boring. Only 5 people died. It's not enough. You know, and then you have to like, I have to increase the number of deaths to make it interesting to them. Like that this disappears. It's really like you do a study, you design the study, do it well, and then you share your data so that there are no discussions. Because I don't know if you, maybe you haven't heard about this, but Dietrich Stapel in the Netherlands, that it was like had articles in Science and Nature, and then it came out that he actually he sat at his kitchen table and just made up data and entered it in Excel and got away with it. By saying like he has these international collaborations. That's saying, oh, right now they have like in this other lab at the other end of the world, they are collecting these data, so you get them next week. Right, and that's also like you have open data, it's much easier to see that somebody like faked it.
Thank you.
If there are no other questions from the public, I have a kind of a trick question for you.
Okay.
Maybe it's not a trick question, but I'm just wondering, do you think pre-registration like this is applicable within let's say, the humanities, where you have, let's say you work with interpretation of texts, and you don't know on beforehand what your interpretation will be, and maybe you're trying to detect influences from other authors or intertext, reuse of text. Would it be possible in those cases to pre-register a sufficiently specific hypothesis? Or is this more, you hinted at this other kind of research, explorative research. Would that more fall into that category?
Yeah, I think some people, they say this pre-registration is only if you have predictions, right? Because then you need to register your hypotheses, right? To really make clear that it becomes before it. If you do exploratory, what's the problem? But there are two parts to it. It's like one, if you say, like how you process the data, right? How you process the text interpretation and so on. There may be like also different tools to do that, to help you with that. And that you say like, I will use this tool, right? So then you could pre-register like the processing steps without pre-registering the analysis. But then this way you would avoid these forking paths. Yeah, because then it's like somebody from the outside would say, maybe you had like, there are 50 different methods to do it. Why did you pick the one that you picked? Right? And then you would avoid it because you said, I picked it and I pre-registered because it's a reasonable choice. Right? And then somebody can say afterwards, no, I think this other one is much better, but then your results should be unbiased. And then maybe the other one gives other results, but then this could be then explored. Does it give different results? And I think another issue is like, depending on then how do you provide evidence for what you have? Do you just summarize the data or do you have actually inferential statistics? Because if you use, I haven't mentioned this at all, but in inferential statistics, it's very often to use p-values, right? Hacking, it's called also, that people chase after significance. When significance is actually only meaningful if you know beforehand what you will do. So the example, what I said, getting 10 sixes in a row, you have to know, you actually, the theory requires that you defined how many times you will roll it. Because then you can compute, like by chance, how many would you expect, and then would you be surprised getting 10 in a row? So, right, so then it depends also, like if you want to do any kinds of statistics, or many statistics require, even for exploratory research, that you define the search space. Otherwise, they're meaningless. So the significance testing, for example, requires that. So it's in the Gelman article also that it's completely nonsense to use significance value, because you don't know how surprised am I supposed to be if I don't know what was the search space and how did you wander through this.
Okay. I have another question if there's one out there. Oh.
Very nice presentation, thank you. Are there any negative aspects in by opening your data?
You mean like by pre-registering or by
No,
sharing
but
your
just
data?
sharing the data.
Sharing the data, yes, people can scoop you, right? They can just they can just use the data and like scripts, for example. We put up our script, so it should be like somebody who has a bigger lab, who they could just do the stuff that I'm doing very quickly, because I'm like, for example, with my graduate student Rasmus, that what we are doing is kind of like new, but we are 2 people. Right, so if another lab has like many more people, they can just download the scripts and just get them to run and just collect data and do it much faster. But I think, so I would be annoyed if somebody does what we are doing now or intend to do like before us by using these scripts, but at the same time I think it's like, that's not what I'm paid for. Right? That it's like my responsibility, like I did this research and now I have to share it to convince other people that this is what we have. And then if somebody builds on it, I think it's actually perfect. So it's like, even though they are maybe like, oh, you know, somebody can exploit this and like rip off your ideas and so on. But at the same time, it has so much more like benefits. Because then a lot of times you develop like analysis methods, and first somebody might look at it and say like, there's a flaw. So I know somebody like Karolinska developed a toolbox, and they said like, somebody emailed him and said like, oh, I downloaded your toolbox, there's an error there. So he said like, it wasn't like fatal, but he was so happy that somebody detected it, like an outsider, and that he could correct the computations. And then also that somebody else can build on it, right? That they don't have to reinvent the wheel. And I think what is also then with this pre-registration open science is really pushed towards going to a non-commercial, like using software that's for free, right? So that it's not tied to like people who have lots of money and university. It's like that it can be used anywhere in the world. That people who have a computer can download it and can use it. So I think that's, so the benefits really outweigh the disadvantages.
So, down there. I think that will be the last question.
Yeah, thank you. Hey, about when you're doing your thesis, sometimes you have the problem with omitted variable. Maybe let's say when we talk about unemployment, and you, of course, maybe you think you are doing a good job, but maybe there are some other opinions about you. Maybe you are omitting some variables there about research. Do you have some good tips about how we can sustain our work, saying, yes, of course, we could have plenty variables, any subjects, but we choose these ones. Of course, our theory will give you us a good backup, but some methods, some good, do you have some tips about how we could minimize this problem without omitted variables? Thank you.
I mean, it's the more we know about variables, I think the better it is. But the trick has been before, the tricky situation has been before that if you say, I have more data, I collected all of these variables, and then you say, but I'll look at these 2. Then the reviewers will say, why did you pick these? Sounds like cherry picking to us, right? So that's where I would say pre-registration would totally help you. You say like, I collect all of these variables. Yeah, so I have all of these data. Instead of just saying like, I'll not collect these data because it's nice to have more data. But then for my analysis, I think this makes the most sense. And then you can pre-register that your analysis will focus on this. And then if you have if a theory predicts this should happen, or another theory, you know, if you have a conflicting theory, you can say like, oh, these variables are most relevant, so I'll use those to see which one predicts better. And then after the fact, you can say, oh, maybe both theories stink. You know, it could be like one theory is better than the other, but both are poor because like if you consider some other variable that you collected, right, but you weren't aware of before, you might get a better explanation. So then it would be exploratory research, but then you could do that too, right? So I would think that it's always best to collect as much data as possible, as is reasonable. You know, not like vacuuming for everything, but like all the ones that somebody might think are reasonable. And then with pre-registration, you select the ones that you think make sense. And then you can, after the fact, you get probably reviewers who say, what about this? What about that? What about shoe size or whatnot? And it's like all kinds of variables. And then you can say, yes, I collected them, so I can address that. I can see, does it make a difference?
Okay. I get it from the questions, too, that we all found your lecture very rewarding and interesting. And we see you're not only a pioneer in presenting the first lunch lecture this year, but also as an advocate of pre-registration. I know there are others working in this direction too. But since you're also an advocate of reuse of things, of data, we have one thing that you can use many times.
Thank you very much.
And inside there's a cup.
Oh, cool.
And I think coffee or tea is the fuel of science together with data. So please feel free to reuse it, and we hope to see you again.
Thank you very much. Thank you.
Thank you.